Good morning, class. Congratulations for maintaining the cleanliness and orderliness of our surroundings. Before we proceed to our lesson, let's pause for a while and feel the presence of the Lord within us. For today's objectives, we have letter A, define a set and an element of set. Letter B, describe and illustrate a well-defined set and a set notation. Letter C, perform the exercises about elements of set through set notation. Objectives in mind, let us now proceed with our lesson. Have you ever noticed that things around us are existing collections of objects? Like the books in our bookshelf, like the collection of shoes in our shoe rack. What about a bunch of roses, red roses? Isn't it a collection of flowers? What about playing cards and the collection of toy cars? Things are existing collections around us. Do you know that this collection have some mathematical properties attached to them? Maybe no, maybe yes. That is why we learn about sets. So simply put, a set is a collection of things. Now, how do we define sets mathematically? Well, what is a set? A set is a well-defined collection of objects. What do we mean by well-defined? It means it does not vary from one person to another. Collections refers to a group, and objects refer to people or things. Remember, a collection of things will be a set if it is only well-defined. Consider this. These are the days of the week. Is it a collection of objects? We know that the days of the week are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So it is a collection of objects. Now it is well defined. I know that the days of the week are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. The answer remains the same for you. Now, if you ask other person, what are the days of the week? They will answer the same, so it does not vary from one person to another. So, this is a well-defined. Therefore, the days of the week is a collection of objects as well as well-defined. So, days of the week is a complete example of a set. Class, let's have an activity about what is a set. Write your answers on your activity notebook for the following questions. Number 1. What are the vowels of the English alphabet? And number 2, why do you consider all the vowels of the English alphabet as a set? You have 1 minute to answer. I'll go around to check how are you doing. Okay, class, your time is up. Let us check your answers. For question number 1, all the vowels of English alphabet includes A, E, I, O, U. For question number 2, it is a set of all vowels because it is a collection of objects as well as well-defined. Class, again, remember this. A collection of things is a set only if it is well-defined. How you know how to define a set? Do you think there is only one way of representing a set? There are 3 ways to represent set. Number 1, roster or tabular set. Number 2, set builder form or description set. Number 3, Venn diagram. Now, let a set denote the colors of a rainbow. What are the colors of a rainbow? Violet, indigo, blue, green, yellow, orange, and red. In rooster form or tabular set, we will make a list of elements of the set and put it within curly brackets. Let's the name the set C for the colors of a rainbow. What are the colors of the rainbow? We will make the list of those as elements and write it within the set C. C is equals to curly brackets violet, indigo, blue, green, yellow, orange, and red, and close curly bracket. I have separated the elements with the commas. Look at this. Every element separated by commas. This is called rooster form. Try writing set in a rooster form for vowels of English alphabet. How will we write it? Take the letter capital V is equal to open curly bracket A, comma, E, comma, I, comma, O, comma, U, and close curly bracket. And this is our answer. Next, do the rooster form for this in your math activity notebook. The set A of natural numbers less than 4. I'll go around to check your work. Class, To check your activity, which are the natural numbers less than 4, 1, 2, and 3 are the elements of set A. So let's write it in a roster form. A is equal to, open curly bracket, 1, 2, 3, and we'll close the curly bracket to arrive at the correct answer. This is included in your assignment. You may now copy and answer your assignment. Thank you. See you next time. God bless us all.
Georg Cantor published his first set theory article in 1874, and it contains the first theorems of transfinite set theory, which studies infinite sets and their properties. One of these theorems is Cantor's revolutionary discovery that the set of all real numbers is uncountably, rather than countably, infinite. This theorem is proved using Cantor's first uncountability proof, which differs from the more familiar proof using his diagonal argument. The title of the article, On a Property of the Collection of All Real Algebraic Numbers, refers to its first theorem: the set of real algebraic numbers is countable. Cantor's article also contains a proof of the existence of transcendental numbers. As early as 1930, mathematicians have disagreed on whether this proof is constructive or non-constructive. Books as recent as 2014 and 2015 indicate that this disagreement has not been resolved. Since Cantor's proof either constructs transcendental numbers or does not, an analysis of his article can determine whether his proof is constructive or non-constructive. Cantor's correspondence with Richard Dedekind shows the development of his ideas and reveals that he had a choice between two proofs, one that uses the uncountability of the real numbers and one that does not. Historians of mathematics have examined Cantor's article and the circumstances in which it was written. For example, they have discovered that Cantor was advised to leave out his uncountability theorem in the article he submitted. He added it during proofreading. They have traced this and other facts about the article to the influence of Karl Weierstrass and Leopold Kronecker. Historians have also studied Dedekind's contributions to the article, including his contributions to the theorem on the countability of the real algebraic numbers. In addition, they have looked at the article's legacy, which includes the impact that the uncountability theorem and the concept of countability have had on mathematics.